Hello and welcome back to programming. This is gonna be episode 2 of the making of Pac-Man, and I get to do this because the other series is not as popular as this one. So in this episode I'll show you how to make the maze for the game. We originally have Pac-Man, which can move anywhere on the screen, but now we want to make the trace, or the street if you like, for the Pac-Man to walk in, and just to block it from the area where we're not gonna allow Pac-Man to be in. So just to get the concept of the game, the Pac-Man move at each time it's going to move 2 pixels at a time. So the whole canvas of the game, the whole screen of the game, is actually just made up of square of 2 pixel by 2 pixel. That means at any time of the game, the Pac-Man would be in one of the square on the grid. So what we really have to do in order to define where the maze, where the Pac-Man can go and cannot go, is to actually just define what grid is walkable and what grid is actually just the wall. So in order to do that, we're gonna have to define a maze. So the maze can be in anything. It can be a table, it can be a string. In this case we'll make it a string of 0 and 1, for 1 being the grid that the Pac-Man can walk on, and 0 is the wall. So for example, if I want 150 column, 150 cells and 50 rows. But remember that each of the cells, I'm gonna call this cells by the way, and we're gonna signify each cell by row and column. So if I have 50 rows and 150 column, I would have the screen as big as 300 pixel by 100, and that's not too big at all. But just to show you how you can actually drawing a maze from here, you can use any other tools, and then for me I would just go something like, if I want that to be my maze, I would have to do something like that. So the Pac-Man can initially start off with this cells and then go right, and then it cannot go further because that is the wall, and it can go up, left and down only. So let me fill in the whole thing. Anyway, you can make it in this case I don't make it too symmetric, and it's not gonna be fun playing on such a simple maze. So I kinda have the idea of making this one. Anyway, if you take a peek at the actual maze, it will almost exactly like that one. So let me show you all of this. So that's kind of big, so it's 260 by 228. Anyway, you're not gonna see only 0 and 1 in there, because in the actual maze you're gonna be defining where the pills are going to be, where are the power pills are going to be for the maze. So I signify the pill position for the cells to be 2 and the power pills to be 3. Actually I have other numbers. There are 4 for the initial Pac-Man position, and I believe 5 is no, 4 is actually for the initial ghost position. That's where the ghosts are going to be spawned, and that is the cells. 5 signify the cell position where the Pac-Man going to be initially in the maze. So let's take this maze and I'm gonna copy it and then making a new file called maze.txt. Now paste all that in. That should be 260 by, that looks about right. So the first thing we're gonna do is we're gonna load up the lines. Now control 1 to fix the import, and then we're gonna load the lines from the maze. That's just one maze anyway, so I was just try to show you just one. Now in order to load that in, I'm gonna be loading using scanner. It's still pretty painful for me to type the code in Eclipse. Hope I would get better in time. So y is still has next line. We're gonna add the next line to the list of lines. Once we're done with that, we're gonna have number of rows is just number of lines. Number of column is basically just let's get the first line and then check for the number of characters in there. We are going to define columns and rows to keep track of the maze size. Now the width of the screen should be column times steps. The height of the screen should be rows times step. That is pretty hard to type. The initial Now we can we have to find where the initial position of the Pac-Man is. The initial position would have to be defined in rows and column. So we're gonna rename X to be, let's give it column, and Y rename it to be row. So where is initially where the row and the column should be? As I said before, the cells indicate the initial position of the Pac-Man is at number 5. So let's try that. If let's read the line in and save it as line first, and then we're gonna do something with the line. If line that contains 5, it means that we found the cells where we are going to put the Pac-Man in. So we're gonna find how do I find? Okay, I use index of character 5. So right now we have row to be R and column to be index of 5. Now that should give us the initial position for Pac-Man. What else do we need to change? Let me scroll down a little bit. We need to change the direction only when let's keep that as key. If key is greater than 37 but less than 40, we are going to change the direction to the key. But if the key code is something else, that means the user hit other keys beside the arrow keys, we simply ignore it. So the direction should be in one of the 4. Now the limitation, we just forget about all of these limitation for now, because it's not only the direction, not only the border of the screen, but also if you want to go left, we would also need to check if the character at row and column -1, that means the character on the left hand side of the current position. So let me remind you that current position of the Pac-Man is row and column. So now if you want to go left, we're gonna need to check the left cell. If the left cell is not 0, and column -1 is not less than 0, we'll moving to the left, meaning we're gonna decrease the column by 1. So that's it's basically all the all the condition in there. so that we're gonna need to create a method called character add. We go there and then say column, meaning the character add row and column. Why is my parenthesis missing? Should not be. So we get the line number row and the character at column position, and return it. Now that's the first condition. The second one should be about the same. We're gonna have to change that to 1, meaning we try to go up. Up mean row has to be greater than 0, and we also need to check that the upper cell, which is row minus 1 column, is not 0. We're gonna do the same for this one. Now we are going to increase until it's less than the maximum column, and we're gonna check the cells to the right of the current. Now for this one, it should be the same. It should be less than maximum rows, and we'll increase it by 1. Now to draw it, we're gonna have to give it the pixel, so we have to get it back to pixel size and subtract it by half of the size of the Pac-Man. So that should be fine, I hope. So let's run that. We can't see anything, can we? We're gonna need to draw the path of the Pac-Man. How do we draw it? We are going to go consider 1 by 1 for R in the range of rows, and for column in the range of columns. We are going to, if character at RC is anything but 0, we are going to, let's fill the whole thing. Give it the pixel coordinate for X and pixel coordinate for Y. The size of the rectangle we're filling in is the step by step. I should have shortened that name. Now that is it. Now the user can go down, left, oops. As you can see, there's an error in there, meaning that it tries to go up, which is not the not the actual behavior of Pac-Man. Your Pac-Man should be moving right, even if you want to go up, because that's not allowed. So your Pac-Man should not be stopped at all unless it's hit it at the end of the maze. So here is the exact implementation of the game. You're gonna need to keep track of two directions. One is the requesting. Okay, let me do that by rename it. Requesting direction. Let's short it with REQ and one with current direction. Let's keep it CUR and DIR. Now initially the request direction and current direction should be the same, which is going right, and whenever the user click on the key, that is the request direction. If now here's the hard part, we're gonna need to check if we can go to the request direction or not. If not, we are going to fall back and go to and use the current direction instead. So here's the logic of it. So if move with request direction success, we are going to, that means we can change direction, else we are going to move along the current direction. Now we're gonna need to define the move. We already have the moving code right there, so we are gonna close that one and make a new one like that. Now we're gonna signify if we can move or not by returning success. So success is 1, fail is 0. So we are going to return int, and that means we successfully moved to the left, so that we will return it success. The same thing for that and that and that. Otherwise, return fail. It's a failure attempt. It's a fail attempt. Now we should be fine. I try to go down. Try to go up. Yeah. Okay. So as you can see, there's one problem with that. It's moving up, but then the image is use the wrong sprite image to draw it. So that is that. we're not using the requesting direction, we're using current direction, so that should fix it. Now I click up, but it doesn't, I mean, it correctly display and use the sprite image. Now you should be doing something like maybe that size, and we can turn this into, alright, let me show you one more thing, because it doesn't seem like the Pac-Man is on the road for the maze, so we actually need to fill rectangle with the actual size of, to fit the size of the Pac-Man. We would go we would make the road to be, to fake it, and then say that is 28 by 28. That would make it bigger, and it seems like Pac-Man is on the road and running on the road. And by now you should have realized that after that it's the graphic designer to draw in the image, or anyone can do it. I think I can show you how to draw it in the next in other video if you want, but I think it's been a long time for this video, so I hope you enjoy it and get it to work. I will put up the maze. The hard part for this one should be the maze, should be making the maze and design it, and so I will post this code inside the Google, inside the link of the video. So hope you enjoyed this one and it's not too boring for you, and I will see you in the next episode. Anyway, if you can tell me, if you can give me feedback on how I should be doing the episode 3, that should be grateful. And thank you for watching. Goodbye.